Well, hey there, kiddos. Hope you guys have had a good weekend. I did. I got to spend all day yesterday building a float and then going to a Christmas parade. It was fun, but I would like to have a Saturday without anything to do, so hopefully next one will be that way. Anyway, we're going to write equations from tables today, which is going to be very similar to what we have already done. We have learned how to write an equation using point-slope forms. You took a point and you took the slope and you put it in that nifty little equation and solved. Then on Friday, you did the same thing, except I gave you 2 points. And so you had to find the slope, then you had to plug in a point-slope form. Today, we're going to write equations given a table. Process is going to be the same. Number one, you're going to have to find the slope. And number two, you're going to have to plug it into that nifty little formula and find the equation of the line. So, let's practice. The first two problems, all you are being asked to do is determine if the data is linear. This is important because if you are given a table and you're trying to write an equation of a line, but the data isn't linear, it won't make a line, and so you can't write an equation of a line. So the first thing you've got to know or be able to do is determine if the data is linear. Here's how we know if the data is linear. The rate of change has to be the same all the way through the table. Okay, so the slope through the entire table has to be the same. So your delta y over delta x has to be the same all the way through the table. So we're going to check both of these using our delta y over delta x, but we're just going to do it multiple times. So right here, my change in y is -1, and my change in x here is 2. So right here, my slope is -1 over 2. So now let's check between the next 2 points and make sure it's still -1 over 2. My change here is -1.5, but my change here is 3. So my change in y over change in x is -1.5 over 3. But if I pull out my calculator or do this division, I will find out that this reduces down to 1/2. So this does simplify down to 1/2. So look, they simplified. They're the same thing. So far, so good. So let's check this one. Okay, from -4.5 to -0.5, or sorry, -5, is a change of -0.5, and this is 1. Well, so my slope is -0.5 over 1, which is the same thing as -1/2. It's because this is 1/2 over 1, which is just 1/2. So my slope is still the same. So let's test the last one just to make sure there's no tricks going on. -5 to -7 is a change of -2. From 4 to 8 is a change of 4. So I have -2 over 4, which is the same thing as -1/2. Since all of my slopes are the same, then yes, this is linear because my rate of change is the same all the way through. All right, now if you look at the next one, we're going to do the same thing, our delta y over delta x, and we're just going to check and make sure it's identical all the way through the table. So my change from here to here, from 11 to 2 is -9. And from -3 to 0 is 3. So my slope here is -9 over 3, which is the same thing as -3. Now let's check our rate of change here. From 2 to 18. Well, now I'm getting bigger instead of smaller, so all of a sudden something has happened. But this is a change of 16. And this is a change of 4. So my slope is 16 over 4, which is 4. These are not the same. Since this rate of change is not the same as this rate of change, this is not linear. If I were to plot these points on a line, they are on a graph, they wouldn't make a straight line. That's what I'm saying. So if you're asked to find out if it's linear, check your slopes. Make sure your slope or your rate of change is identical all the way through. Now let's write some equations. It asks for both of them in slope-intercept form, so we get the easy part. Now, they are not going to ask you to write an equation of a line from a table if it's not linear. So you're not going to have to go check it first when it's posed to you this way. You might run across one later on where you have to double check to make sure it is linear, but we aren't going to have to check it. It says write an equation of the function in slope-intercept form. It's going to have to be linear. So let's do our first things first. We have to find the slope. So from a table, we find the change in y over the change in x. So my change in y from -13 to -10 is +3. And from 5 to 10 is +5. And so my slope right now is 3 over 5. If you want to test it just to be safe, from -10 to -7 is also +3. And from 10 to 15 is also +5. My rate of change is the same. So now I have my slope. Point-slope form. In point-slope form, I have to have a point and the slope. I have 3 points to pick from. It doesn't matter which one you choose. Makes absolutely no difference. I'm going to use this one right here in the middle. That's what I'm going to plug in, but it doesn't matter. So y minus y1, and my y1 is going to be negative 10, so this becomes plus 10, equals 3/5 times x minus x1, which in this case is 10. Now I distribute, so I have y plus 10 equals 3/5 x. Now, 3/5 times 10, 3 times 10 is 30, and 30 divided by 5 is 6. And I want it in slope-intercept form. That means y by itself, so I'm going to subtract 10 from both sides. And the equation of my line is y equals 3/5 x minus 6. So there's my equation. Nothing new really happened. I found the slope from a table. I plugged it into that same formula I've been using. Now look at the next table. And hopefully when you look at this next table, you see that the y is the same all the way through. That's going to be really important in just a second. Okay? Step 1, find the slope. Change y over change in x. Well, my change in y from here to here is 0. My change in x from here to here is 1. So my change in y and change in x is 0 over 1, which is just 0. Please think back to what, and we have done this, feels like 1,000 times by now. What kind of lines have 0 slope? Horizontal lines have 0 slope, and their equations are always y equals. If you look at the table, what does y equal all the way through that table? No matter where you are in the table, y equals 9, so the equation of that line is just y equals 9. If this is not something you can remember, you can plug it into this formula. We can take a point, just grab the first one. Y minus 0 equals 0 times x minus, sorry, it's y minus 9, not y minus 0. Y minus 9 equals 0 times x minus 0. Well, this entire side becomes 0. So I have y minus 9 equals 0. When I add 9 to both sides, I still get y equals 9. The equation is the same. This is shorter. If you'll remember, your HOI means y equals, and what does y equal? So that's from a table. One last example, okay, because this is not given as a table. You're asked to write an equation in standard form. We got to practice this, representing this data set. Well, it's not given to you in a table. So guess what? Step 1, we're going to make a table. X, Y. My first point is 2, 4. My second point is 6, 6. And my third point is 12, 9. Now I have a table. I can go find my slope and plug it in. So change in y over change in x. My change in my y values is 2. My change in my x values is 4. So my slope is 2 over 4, or 1/2. If you want to check this, it's 3 over 6, which is also 1/2. So my slope is 1/2. Now pick a point, any point. Let's use this first one because it has the smallest numbers. So we're going to do y minus y1 equals the slope times x minus x1. Distributive property, y minus 4 equals 1/2 x minus 1, because half of 2 is 1. And we want standard form. So let's go ahead and add 4 to both sides. So I end up with y equals 1/2 x minus 3. Now I've got to get this over here, so I'm going to subtract my 1/2 x. And I always put my x first. You do not have to. So I end up with negative 1/2 x plus y equals negative 3. But I've got two problems. Number one, my a is negative and I have a fraction. So I've got to multiply the entire thing. And I'm going to multiply by negative 2 so I can cancel out the negative and the 2 all at the same time. So that leaves me with 1x. And then I have to do negative 2 times y, so I end up with minus 2y. Then I have to do negative 2 times negative 3, which is positive 6. So in standard form, it's x minus 2y equals 6. There's my equation of my line. So that's writing equations from tables. As you can see, I haven't changed a whole lot. We've just gone from here are the 2 points to now take it from a table. Process is exactly the same. Hopefully by the end of this week, you are really, really good at writing an equation of a line because we are going to do point slope form. All right, I will see you guys tomorrow. Have a good rest of your day.